Now question is as in a starting of a lecture we say that if we able to find out these constants, means these unknowns, not a constant, these unknowns with the help of a Legendres polynomial, then that's why we say that, means this is a Gauss-Legendres integration method. Means we able to find out the values of a lambda 0, lambda 1, x 0 and x 1 with the help of a Legendres polynomial. That's why its name is a what? Its name is a Gauss-Legendres integration method. So how we derive the Gauss, means how we find the values of x 0, x 1, lambda 0 and lambda 1 with the help of a Legendres polynomial. So as we know that Pnx equal Rodriguez formula is a what? Formula for generation of a Legendres polynomial. So here we write what? Rodriguez formula. Rodriguez formula. Rodriguez formula. Rodriguez formula. So here we write a what? Rodriguez formula. What is the Rodriguez formula? Rodriguez formula. So not the Rodriguez. So here if we write what? Erase out this one. Rodriguez formula. So what is the Rodriguez formula? Pnx equal 1 upon 2 the power n factorial n dn upon dxn to power n x square minus 1 to power n. So in order to find out 1 point formula, we write what? N equal to 1. So P1x equal to what? P1x equal to 1 upon 2 the power 1 factorial 1 dy dx of x square minus 1. X square minus 1. So if we simplify this become 1 upon 2. D by dx is a what? D by dx is a twice x. D by dx of x square minus 1 to power 1 is a 2x. 2 cancel out. So P1x is a what? P1x is a x. P1x is a x. So if we put this one equal to 0, means by putting P1x equal to 0, the values of x is nothing else, nodal points. So here P1x is a x equal to 0. So what is the nodal point? Nodal point is x equal to 0. X equal to 0 is the nodal point. So if we put P2x equal to 0, P2x equal to 0, then we find two nodal points x1 and x2, x0 and x1. So here P1x equal to this one, P1x equal to 0. If we put P1x equal to 0, then we find the x equal to 0 and we denote this one is x0 equal to 0. This one is a nodal points. And how we find the weight? In order to find out the weight, lambda 0 equal to integrate minus 1 to 1 means L0x. Here we write L0x dx. So as we know that L0x, here this one is a 1. So this one is a minus 1 to 1 dx and this get the 2. So what is the value for lambda 0? Lambda 0 equal to 2 and x0 equal to what? X0 equal to 0. So what is the formula? Formula become what? Minus 1 to 1 fx dx equal lambda 0 f of x0 and here lambda 0 be the 2 f of x0 f of 0. So this one is the same as we derived earlier. So this one is a 1 point formula. In a similar manner, we also able to find out a 2-point formula by putting what? P2x equal to 0. So, what is the P2x? P2x here in a Rodriguez formula. In Rodriguez formula, if we put what? N equal to what? N equal to 2. If we put n equal to 2 here n equal to 2, then if we simplify, then be able to find out what? P2x. P2x become 1 upon 2 square factorial 2 d square upon dx square x square minus 1 whole square. So, P2x become what? 1 upon 4 into factorial 2 become 2, and d by dx of a one time differentiation of this become what? 2 time of x square minus 1 into twice x. Once again, if we differentiate, this become 1 upon 8 into 2 to the 4 into 4 outside, and this become d by d of dx of x cube minus x. So, this become inside 3x square minus 1, 3x square minus 1. So, 4 and 4, this one is a cancel out. So, this one is a cancel out, this become x cube minus x. So, this one. So, P2x become what? P2x become what? P2x become 3x square minus 1 by 2. If we put what? P2x equal to 0. Here if we put this one equal to 0. So, if we put this one equal to 0, this implies that 3x square minus 1 equal to 0, and this implies that 3x square equal to 1 and x square equal to 1 by 3, then x be the what? X be the plus minus 1 upon under root 3. So, one nodal point is a 1 by root 3 plus 1 by root 3, and another nodal point is a minus 1 by root 3. So, what is the value of x0? Here we assume that x0 is a plus 1 by root 3 and x1 equal to what? X1 equal minus 1 upon root 3. These are the two nodal points with the help of a Legendres polynomial. Now, how we find the nodal points? Lambda 0 equal minus 1 to 1 L0 x dx, and lambda 1 equal to minus 1 to 1 L1 x dx, where L0 x and L1 x is a what? These are the Lagrange multiplier, Lagrange coefficient of a Lagrange interpolation formula. So, what is the value of L0 x? With the help of a Lagrange interpolation formula, L0 x become what? There are 2 points. With the help of these 2 points, we find the what? We find the L0 x. So, what is the L0 x? X minus x1 divided by what? X0 minus x1. This one equal to what? X minus x1 be the minus 1 by root 3. So, minus minus become plus 1 upon root 3 divided by what? X0 be the 1 upon root 3 plus 1 upon root 3. So, this one is the value of L0 x. And similarly, what is the L1 x? L1 x is a what? L1 x is a x minus x0 divided by x1 minus x0. So, what is the x0? x0 is a x minus 1 upon root 3 divided by x1 is a 1 upon root 3 minus 1 upon root 3 minus 1 upon root 3. So, if we put the values of L0 x here and L1 x from here and simplify, then we get what? Lambda 0 equal to 1 and lambda 1 equal to 1. Lambda 0 equal to 1 and lambda 1 equal to 1. So, if we here we try to find out a one value, another value, similarly we find the another value. So, how we calculate the value of a lambda 0? Lambda 0 equal minus 1 to 1 L0x. L0x is a what? X plus 1 upon root 3 divided by 2 by root 3. 2 by root 3 dx. So, if we integrate this one, this become what? Root 3 by 2, root 3 by 2. Inside this become x square by 2, x square by 2 plus 1 upon root 3 x, this become minus 1 to 1. If we simplify this one, the value of a lambda 0 become 1. Lambda 0 become 1, and similarly lambda 1 become what? Lambda 1 become 1. So, what is the formula? Formula become what? 2-point formula become 2-point formula become 2-point formula. 2-point formula become what? 2-point formula become 2-point formula become minus 1 to 1 fx dx equal lambda 0 f of x 0 plus lambda 1 f of x 1. So, lambda 0 be the 1, x 0 be the f of plus 1 upon under root 3. Plus lambda 1 is a 1, f of what? Minus 1 upon under root 3. So, this one is a what? This one is a 2-point formula, fx dx, 2-point formula, 2-point formula, 2-point formula. So, in order to solve a numerical example, there is a need to remember the Gauss-Legendre integration methods formulae for 1-point formula, 2-point formula, 3-point formula, and so on. So, once again here we write. So, what is the 1-point formula? 1-point formula become minus 1 to 1 fx dx equal to 2 times of f of 0. This one is a 1-point formula. 2-point formula minus 1 to 1 fx dx equal 1 into f of 1 upon under root 3 plus 1 f of minus 1 upon under root 3. 3-point formula become minus 1 to 1 fx dx equal 5 by 9 f of under root 3 by 5 plus 8 by 9 f of 0 plus 5 by 9 f of minus under root 3 by 5. 3 by 5. So, this one is a 1-point formula, 1 point, this is a 2-point formula, and this is a 3-point formula, 3-point formula, 3-point. So, what is the summary of this lecture? In this lecture, we derive the Gauss-Legendre, means we define the Gauss quadrature general form of integration, numerical integration. Then we define we convert the general form of integration into a Gaussian form of integration by using the x equal b minus a by 2 t plus b plus a by 2, and obviously dx equal to dt by 2. So, b minus a by 2 dt, not for a particular case dx equal to dt by 2, but in general dx equal to b minus a by 2 dt. So, once we convert the general form of integration into a Gaussian form of integration, then we apply the Gauss-Legendre 1-point formula, 2-point formula, 3-point formula as per the need of a question, and find the values of f of 0, f of 1, f of means f of 0, f of 1 by root 3, f of minus 1 by root 3, f of root 3 by 5, f of 0, f of minus root 3 by 5, and putting here, then we able to find out integration from minus 1 to 1 fx dx with the help of a Gauss-Legendre methods. So, any integration can be solved with the help of a Gauss any numerical integration can be solved with the help of a Gauss-Legendre method once we convert the given integration into a Gaussian form. Once we convert into a Gaussian form, then apply the 1 point, 2 point, 3 point Gauss-Legendre formula, then we able to find out the value of integration with the help of a Gauss-Legendre integration method. So, in the next lecture we solve some numerical example based on a Gauss-Legendre method. Thank you for watching my lecture. Thank you very much.